Can you do that? I can do that. Okay. It's my pleasure to introduce Mike Miller, who's a stream ecologist with the Wisconsin DNR. He's also a lecturer at UW-Madison and happens to be the co-author of the Field Guide to Wisconsin Streams. And he is going to talk to us today about the risk posed by neonicotinoid insecticides to, and I added something, Mike, Wisconsin and Illinois streams and rivers. So Mike, take it away.
Folks, if you could have a seat, please. I'd appreciate it if I could have your attention. So I think I have the distinction of having the most depressing presentation of this summit, but I make no apologies. You folks as ag producers or watershed managers, water resource managers, advocates for land and water resources, I think what I have to present today is relatively important, so I'm hoping I can have your attention, please. So neonicotinoid insecticides, they first became commercially available in 1993. Since that time, they are the most widely used insecticides in the upper Midwest, United States, and globally. So these chemicals are used throughout the world, 129 different countries use these chemicals. Recently, there's been some evidence that, frankly, strong evidence that these chemicals are having strong environmental effects on our aquatic resources, in particular, and affecting a lot of the both terrestrial and aquatic invertebrates. And also, there's a very strong amount of evidence that suggests that these chemicals, depending on the crops being produced, have a little benefit to the ag producers as far as increases in crop yields are concerned. So the next 20 minutes or so, what I want to talk about is what these chemicals are, where they're used on the landscape, talk about the risks they pose to both terrestrial and aquatic environments. Then I'm going to offer some preliminary findings from some survey work of streams in Indiana, Wisconsin back in 2022. Okay. Off to a great start here. So my advanced seems not to be working. We have our tech support guy.
Is this clicking? Now it works.
No, all right. Excellent. Thank you. So my alternative title is "Where Have All the Insects Gone?" Back in the bad old days, truck drivers, farmers, others would put screens on front of their radiators of their vehicles because they get so plugged up with insects over the course of the summer. Nowadays, not so much. And people argue, and I go along with this to some extent, well, vehicles are much more aerodynamic these days. I personally drive home Volvo 240. They're affectionately referred to as Swedish bricks. And they're about as aerodynamic as a chest freezer. So I don't necessarily buy that argument when I'm driving around the countryside and not seeing any insects getting crushed by my car. So I want to, again, as mentioned just a minute ago, I want to cover a few different topics here, what these chemicals are. I'm going to use the term neonics from here on out. Neonicotinoids doesn't exactly roll off one's tongue. So I'll talk about what they are, their uses, again, the risks they pose to both terrestrial and aquatic environments. And lastly, we'll talk about some recent findings from some survey work done in Wisconsin. So we're seeing this photograph here is the underside of a leaf, of course, and we have aphids feeding on that leaf. They're insect pests for many different crop species, and they feed on the phloem or the sap of the leaves. As you can read here, a number of different plants over millennia have evolved chemical defenses to ward out these insects, and now these chemicals are now commercially synthesized for use as insecticides. Some key points about neonics: they disrupt the neural systems of primarily insects, but other animals as well. And some other key points that I've underlined here: that one, they bind permanently to the neuroreceptors of these animals. So the point is, the longer that animal lives in the environment, the greater the dosage or exposure they're going to have to these chemicals. So the effects are additive. So that's a big deal. If you're a little mayfly that lives in the stream for 6 months before you emerge as an adult, you get a certain dosage of those chemicals. If you're a different aquatic species that lives for 2, 3, 4 years as an insect in a stream, a larval insect, you get a much greater dosage. So that's kind of a key point. And also there's a number of these different chemicals that are used across the country, but they all have the same mode of action as far as the impacts on aquatic life. So it's an additive effect. So when we're measuring different chemicals in the stream, we add up those concentrations because the effects are indeed additive. And also these chemicals are offered by chemical companies as being safe. And that's relatively true for mammals and other vertebrate species, but again, they're extremely toxic to a lot of different invertebrates, insects in particular, and many of those are non-target organisms. They're not pest species we're trying to wipe out, but fundamentally important organisms in our streams and other aquatic environments. So you kind of scroll through a list of different uses of neonics. So in the upper Midwest, by far, in a way, the greatest application is on seed coatings for particularly grain crops prior to planting the seed. So the vast majority of these chemicals used in the Midwest, it probably holds true for the United States for that matter, is again being applied to the seeds prior to planting. But also during the cropping season, as the crop plants emerge and there's maybe an outbreak later in the growing season, they can spray these chemicals onto the plants themselves. There's also granulated applications, and you can think of like green spaces in city parks, green spaces in urban areas or pasture areas where they're trying to control pest species that affect turf plant species. And also they're used as root drenches. You can, an example being emerald ash borers, for example, where you'll inject these chemicals into the soil at the root ball of these trees, and it's taken up by the trees and offers them protection from ash borers and other tree pests. They're also used as baits in urban areas in particular. They're applied in urban areas to control cockroaches and ants and other deemed pests in urban areas. And also there's topical applications, whether it's for livestock or for your pets to control fleas and ticks. So again, the primary use of these chemicals is applying to the seeds that are planted, and again, irrespective of whether there's an outbreak of pests or not, and these seeds are being planted with these chemicals on them. So I refer to that as a prophylactic use. And for decades, ag producers used integrated pest management strategies where, again, they would not apply chemicals unless there's some sort of outbreak on the landscape. They'd rotate crops, so there would not be a buildup of pest species in the crop fields, that sort of thing. So the fact that they're now using these chemicals, I feel that a lot of ag producers kind of walk away from this IPM process of integrated pest management. And even if a producer does not want to use these chemicals to planting corn, they almost have no choice but to plant corn that has these chemicals already pre-treated on the seeds. And that holds true to a large extent for soybeans as well. So I'm going to walk you through a time series of the use of these chemicals. Again, they first became commercially available in 1993, and I'll have a few dates here I can show you. So the darker the color of these slides represents a higher concentration of neonics being applied. If you're seeing kind of a patchwork of counties in the respective states, it's not because they're not using it within those counties. The fact is, it's just the reporting is fairly poor as far as the usage of these chemicals. So starting in 1995. So I think I'm seeing a trend here. And unfortunately, I don't know the policy behind this, but since 2015, these chemicals, when they're applied on the seeds, are no longer recognized, as I dimly understand it. I could be wrong, but the point is they're not tracked in any great extent anymore. So again, this is the most recent data we have is from 2015. So that's a little bit disturbing that we don't have a good understanding of the true usage of these chemicals on the landscape. Some key factors you should be aware of as far as the effects on aquatic life and terrestrial life as well. Again, the reason they're very effective, or sometimes effective in controlling pest species, is because they're water soluble and they get distributed throughout the plant, so they can protect against insect pests that attack the roots or the stems or the flowering bodies or leaves or whatever. But that also makes them very mobile in the environment if they're water soluble. And also you can see here they're fairly long-lived in the environment, depending on a lot of different environmental factors of the soil itself. We do see a buildup of these chemicals in our soils over time. And also, again, there's a handful of studies that suggest that the vast majority of these chemicals wash off the seeds before they're even taken up by the plants. So the producers and the plants they're trying to grow are receiving little benefit from these chemicals. So this is a very interesting study. For those that may doubt my words here, I highly recommend that you look up this study by Grout and others. It's done by Cornell University. It's a 400-page report. It's sitting on my kitchen table right now. An extremely extensive study where they looked at hundreds and hundreds of different test plots across the country to look at the effectiveness of these chemicals. So again, using corn as the first example here, where they looked at a variety of different test plots in over 300 studies, 15 different states. It's a very impressive effort as far as this body of literature. So for those that want to learn more about these chemicals and their impacts and benefits to ag producers, I highly recommend you get a copy of this Grout report. But the take-home message here is you can see that these were field corn. The vast majority of these test plots indicated that there's no increase in crop yields when ag producers are in these test cases. They're applying these or using these seeds with neonics applied to the prior planting. And then another example using soybeans. Again, a very extensive survey of the scientific literature, hundreds of studies done, multiple states, several provinces. Again, the take-home message is that the vast majority of these tests indicate that there's no increase in crop yields when you use these chemicals. So a key point I'm hoping you kind of take that there. And also it should be noted, and I've drawn a blank on the exact numbers, but these increases in crop yields oftentimes are very nominal, and upwards of like 40% of these tests where there was an increase in crop yields, the benefit, the economic benefit of that yield and increased production did not offset the cost of the chemicals themselves. So again, more corn, more soybeans are being produced, but it's a very negligible amount. So why is that happening? And this illustration, I think, does a good job explaining this. And this study was done by Martinez and others. He's a researcher at UW-Madison, Indiana State University. There's probably about 5 or 6 different universities involved in this particular study. So I think it's pretty comprehensive and well respected. But what I'm trying to illustrate here is this wedge here, this salmon-colored wedge, represents the concentration of neonics in the seeds and in the surrounding plants. So the point being is, by the time aphids come about in the growing season, these chemicals have washed out of the plants. So again, they're relatively ineffective at controlling these aphids in these particularly soybean studies. So what are the risks of these chemicals to the environment? So I suspect a good number of you folks have never heard of neonicotinoids until today, but I suspect most of you have heard of colony collapse in honeybees. So this LD50 information I have on the screen here, what that is during toxicity tests, they'll dose the animals with a certain concentration of these chemicals, and that concentration where 50% of the test organisms die, that's the LD50. The take-home message here is that 5 nanograms of neonics is enough to kill 1 honeybee. 5 billionths of a gram of neonics is enough to kill a honeybee. And these chemicals are thought to be 10,000 times more toxic than DDT. So a little analogy here, you can read as well as I can, but a quantity of neonics the size of a sugar granule that you have in your little sugar packet is enough to kill 125,000 bees. 1 granule, 125,000 bees. I'm going to continue with that analogy. So a little sugar packets, perhaps some of you folks are using this morning. So again, extremely toxic chemicals. So I live in Madison, Wisconsin. Perhaps relative to you folks, we didn't get much snow this winter. Well, actually, I took this photograph in June. So what you saw are mayflies, hexagenia mayflies. They're one of 115 different species of mayflies in the state of Wisconsin. So a number of different species, but just using this one example, and they have these massive emergencies. You can see these emerging on the Mississippi River. So what do we got going on here? So this is a time loop, as you can read from NOAA weather radar. And those are going to be familiar with the cross county. So we got the Mississippi River here that's the boundary, of course, between Minnesota and Iowa and Wisconsin. So what we have here is a mayfly emergence on the Mississippi River. The numbers are so great, the numbers of individuals are so dense, they're showing up on weather radar. And we've seen this in other parts of the country as well. So, interesting, there's a study done by Companion and others. They're actually using radar to track the emergencies of these insects. So, a little life history story here. So, these insects spend much of their life, the hexagenia spend about 2 or 3 years of their life in immature larval stage on the bottom of many of our lakes and rivers. And at some point, they'll emerge as winged adults. Again, they're using weather radar and determine that upwards of 80 billion with a B of these mayflies emerge in just one hatching or emergence of these insects. And these occur multiple times throughout the summer from late June into early July. And it's thought that upwards of 3 tons of biomass, 3 tons of mayflies are hatching out at any one of these emergences. And a lot of different animals key in on this food source when they're reproducing their young. So a real key link in the food chain. But disturbingly, they're seeing a decline upwards of 50% in the emergences of these mayflies. And the neonics are just one suspected cause of this problem. But you're not only seeing this on the Mississippi River, but Western Lake Erie, for example, is another key area where we see these emergencies. So we're seeing big declines in these various species, and mayflies tend to be more environmentally sensitive to a number of different aquatic vertebrates. So it's occurrence in Wisconsin, again, findings from some sampling we did in 2022. So kind of some nerdy stuff about, as a scientist, I feel compelled to offer this, but so we looked at wadeable streams, we stratified the sampling effort by land use. We'll back up a little bit. I'll offer that Wisconsin has 42,000 miles of streams in the state. We took all those streams and lined them up end to end and straightened them out. We could encompass planet Earth 1.7 times. So we have a lot of stream miles in the state of Wisconsin, as does Illinois and other states. But the point from a sampling design, we need to do a random subsample to characterize the resources. So we did this random draw of 125 sites. And we also had some watersheds where we sampled the same streams over and over and over throughout the course of the summer to see how concentrations of neonics changed over time, and also what happened with these concentrations after rainstorm events. So you can just, not just, but you can see the distribution of the sampling sets across the state, color-coded by the different watershed types that we're looking at. So the dominant land use in these various watersheds, whether it's an urban watershed or in the central part of Wisconsin, there's an area called the Central Sands, and it's dominated by vegetable cropping because there's very sandy soils that's very conducive to potatoes and snap beans and carrots and those types of vegetable crops production. And then also, I looked at a watershed with just row crops. I defined that as being dominated by either corn production or soybean production. And lastly, I did a random draw statewide, irrespective of land use, to characterize the entire state. So this is what one of these hexagenia mayfly larvae look like. And then it's not going to be important to this slide, but just give you a feel for what these animals look like in the immature stage. But so we collected all this concentration data of neonics in the streams. So to interpret the data, we used some laboratory data from Morrissey and others in 2015. They took data from 29 different toxicology studies, and they had some pretty good understanding of what concentrations various invertebrate life would either have chronic effects of these chemicals or acute effects, death. So that chronic effects would be things like loss of motion or behavioral changes or reduction in growth and other things. One example of these mayflies, they live on the bottoms of rivers and lakes in soft sediments, and they live in a U-shaped burrow for a couple of years, 2-3 years. But the point is, they saw in this one study where these animals would just vacate their burrows and get in essence washed down the river. So it didn't kill them immediately, but in all intents and purposes, it means death to that population. The same thing holds true for honeybees. Again, they sometimes have difficulties finding the food patches or communicating to their hive members where the food patch is or finding their hive. So again, we see reports of toxicity as well. It didn't kill them, but in essence, if you can't find your way home, you can't find food, kind of writings on the wall for their existence. So I suspect this may not be all that visible for people in the back of the room, but I want to show you here's the distribution of the concentrations of these chemicals we found in the streams. And sort of in the world of scientific reporting, these are called boxing whisker flies. So there's whiskers at the bottom. At the bottom, that whisker represents the lowest concentration we found in that population. So that first one would be the urban population, and the vegetable crop watershed population, and row crops, and then statewide. And then I offer those thresholds of chronic toxicity, and where it's thought that these animals are being impacted by the chemicals but not being killed outright, and also the acute toxicity, where at those concentrations in streams we believe it's enough to kill the animals outright. But just my sheet, these are pointing out that for this bottom one, for example, the lowest concentration was at this level, roughly maybe 5 parts per trillion. This box here represents 50% of the data. The X represents the mean concentration. The horizontal bar represents the median concentration. So that being said, half the streams have concentrations below that value, half that above that value. So again, the urban settings, it's problematic. There's chronic toxicity. If you look at the vegetable crop watersheds, very problematic. We have issues with our watersheds dominated by corn and soybean as well. So I think based on these data, we have some fairly compelling evidence that we are impacting our streams by the use of these chemicals. And just another part of the sampling design, you don't need to worry about the details of the numbers of sites or names or anything like that, but then we look at 3 different watersheds where we sample the same streams over and over again. And since this was close to home for me near Madison, this Black Creek watershed, and there's 13 different stream sites. Some of them are on the same stream, but we did sample the stream sites over and over, and that's an understanding of how these chemicals change over the growing season and also the concentrations during storm events. So busy slide. Last Sunday, I spent the vast majority of Sunday compiling this data, interpreting it, and making this one stupid plot. So I'm hoping you will appreciate it. What I will say is that, again, these watersheds, this watershed, all these different streams in the Black Creek watershed, we sampled them 6 different times. Once in the blue days or when it's during haze flow conditions, that is water that's coming from the ground primarily, it's not surface runoff. We get those salmon colored events where there's a rainstorm event, I went up to sample the streams after the rainfall event. So the take-home message in all of this is that during storm events, we have a much greater concentration of these chemicals than we do during haze flow. And another fairly important thing is these 3 sites of Black Creek, this morning is a headwater, that's the kind of middle of the watershed, downstream reach. But what we're seeing is increases in the concentrations of chemicals as we go from headwaters to the north. And that trend seems to hold true for the majority of the sites where we had more than one sampling location. And some other findings, this is not particularly important, I guess, as far as your world's concerned here. Again, we had into the lab analyze for neonics, and we found that, depending on the compound, and some of them have different toxicities to different invertebrates, so that is important. But I think the take-home message for you folks here is of those 115 random sites across the landscape, 85% of the streams have detectable levels of neonics, so they're well distributed in the Wisconsin environment. Now, my title slide, I said impose the risk posed to Wisconsin streams. Well, neonics are really poor evaporators, so I suspect these impacts that are occurring in Wisconsin are also occurring across the border. So it's not a Wisconsin specific issue. And another finding was just based on these concentrations from the toxicity tests and what we're seeing in the streams, we have an estimate of what we think the proportion of streams in the state are being impacted by these chemicals. Now, these data are very preliminary. I need to do some weighting, some kind of statistical rooted to the data, but the point is that I think the results are fairly close here. Don't commit this to memory, but just recognize that we're seeing significant impacts toward surface waters. And another slide. So I had two different labs. I feel to mention this in the outset of this talk, but so the focus has been on these neonics. And so I had this laboratory at Wayne State University analyzed the water samples for neonics, and then we split the samples and sent the other half of those samples to a lab, an EPA lab in Athens, Georgia. And I just got that data back like a month ago, and I had little time to react to it. But again, back to my theme of this pressing presentation, again, we have neonics in all these streams. Again, this is just one subsample of our statewide effort, but the kind of scary thing is that the EPA lab was detecting all these different chemicals in these water samples. And I use it, I say greater than 50%, actually 50%, actually greater than about 80% of these 25 samples. But in July, all had those chemicals in them. So I need to start teasing those apart. Some of those are insecticides, some of those are herbicides, some of those are fungicides. They all have different potential risks to the invertebrate life and other life in our aquatic resources. So that's kind of my mission for the next 6 months or so, is to tease apart these data so we better describe the potential impacts on the landscape. So I'll kind of leave this as perhaps one parting shot here. So E.O. Wilson, he was a Harvard professor. He unfortunately died 2 years ago, I believe. He's the world authority on ants. But more importantly, he is his message here. That again, we tend to fixate on the megafauna, the rhinos and the giraffes and polar bears, all good stuff. But as far as the function of the world is concerned, at least in the natural world, the invertebrates are much more dominant and frankly much more important than the things we kind of fixate on in the environment. And I'd offer as an entomologist, or stomachologist anyway, so this Hexagenia mayfly, family Hydrocyclidae, and they're kind of interesting little fellows. They're close relatives to moths. They have a silk gland, and they spin this little web, and they filter the organic matter that flows through the stream. So they spin these webs on the bottom of the stream. Now, at least in the streams that I work on in Wisconsin, these animals, these hydrocyclids, make up about 1/3 of the biomass in our streams. So these Hexagenia are drab little fellows, about so long. They have a Latin name about this long. So who cares about these crummy little Hexagenia caddisflies? Again, since they make up 1/3 of the biomass in our streams, if we lose these animals, say goodbye to 30% of the fish biomass, 30% of the water snake biomass, 30% of the kingfisher biomass, you go up and up the food chain. So these non-scriptural animals that live on our stream beds are fundamentally important for the function of our aquatic resources. So just to quickly review, again, we use these chemicals widespread across the landscape. Again, these studies done at Cornell University provide some pretty compelling evidence about the utility of these chemicals, at least particularly for grain producers. The fact that these chemicals accumulate in our soils, build up in the soils, and get mobilized in water, that's a concern. And lastly, based on these recent studies, we're seeing concentrations of these chemicals in our streams and rivers. No doubt, I believe this will be found in our wetlands and lakes as well, but there are concentrations that are affecting aquatic life. And I had a lot of help on this project. I want those folks to be recognized. So give them their 30 seconds in the sun. With that, I think I have all of like 1 minute left. If anybody has any questions, my contact number there, please think of me as a resource. If you have questions, do not hesitate to contact me, and hope you found this value. Thank you. Questions? Jesse.
Yeah, so I'm going to reference your present bar chart since you took so much time on it.
Yes, thank you.
It is a lot of the inputs are coming from surface water, but can you tell how much is coming from ground through the soil or groundwater sources?
I do know there's been some recent studies, again, in the central sands part of the state, so it may not hold, sorry, So it may not hold true for Illinois and Wisconsin in general, but there's some recent studies. I've not looked at the data, but they've looked at kind of lateral flow off the landscape, kind of shallow drainage. So there's some data out there. You do know Wisconsin Department of Ag has some good groundwater data, and there's been some studies in central sand. So I think there's some reasonably good data out there. I just can't offer you any specifics. But thanks for asking. Yes.
You said you had Honey Creek on there. Is that from Milwaukee Honey Creek?
It is, yes. Yes, actually, folks from SewerPack helped collect those data. I'm grateful for them for that. Yes.
I thought I heard recently that somebody was trying to get cancel
Okay, I'm not very ignorant about policy issues. I would offer that, again, the chemicals aren't being tracked as closely as they once were. I don't understand why that is. I can offer that the Wisconsin Department of Natural Resources is looking to develop water quality standards for neonics. So we're starting that conversation. That's great. Then we need to have a better understanding of these impacts, and also, if there's obvious impacts, we need to obviously, curtail their use if need be. So thanks for asking about that. Yes, sir.
We heard recently that one of the big box stores was bringing in shipments of pollinator plants from Florida that were treated with neonic. Are you familiar with that?
I'm not, but one of my slides I indicated that there's over 500 different products licensed for use in the state. So in addition to those plants that are perhaps pre-treated, I've not done it myself, but I suspect you did an inventory of the chemicals in your home store. You use some number of different products that have neonics in them. So I'm concerned about that, frankly, more than the plants, but no doubt an issue. I'm glad you brought it up. So I'm out of time. I appreciate your attention, and I'll speak to anyone afterwards if you have questions.
So our next talk will shift gears a little bit in the topic, but I'm pleased to introduce